Hello, welcome to my poster video on visualizing tripartite synapses in amyotrophic lateral sclerosis, or ALS. ALS is a neurodegenerative disorder characterized by a loss of motor neurons in the brain and spinal cord that ultimately lead to deficits in motor control. We believe that changes may be occurring at the synaptic level within the nervous system that lead to these pathological changes. Equally, we think that astrocytic support cells in the nervous system may be dysfunctional. Astrocytes make specialized contacts with synapses known as tripartite synapses. So we wanted to visualize both synapses and tripartite synapses in a thorough quantitative way throughout the nervous system to understand how they are affected in ALS. We used a mouse model which expresses PSD95 EGFP, which allows us to visualize postsynaptic densities throughout the nervous system, and used a few different ALS mouse models, including the SOD1 G93A mouse, which shows a clear motor phenotype, and also a C9orf72 mutant mouse, which in our hands doesn't show any motor phenotypes. We performed high resolution and super resolution microscopy across the lumbar spinal cords to generate anatomical maps of synaptic level changes in ALS from analysis of millions of synapses. To summarize some of these findings, one of the key things we observe is that in male SOD1 mice, they show both a loss of synapses and a reduced size of their synapses at 16 weeks of age, which is prior to any severe gait or motor neuron loss. Using super resolution microscopy of PSD95, which forms nanoclusteral scaffolding domains inside the synapse, we observe that there's a reduced number of these nanoclusters per synapse, which may reduce the synaptic strength. When visualizing tripartite synapses using antibody labels for vGlut2 and astrocyte markers such as EAAT2 and p-esrin, we observe a loss of tripartite synapses, which may impact the glutamate clearance process from the synapse. Finally, one particularly interesting observation is that we've observed a reduced content of a protein called DHHC2 at the synapse. This protein is a palmitoylating protein which helps PSD95 to form clusters at the synapse and may explain some of the postsynaptic alterations we observe in our data. So please come and take a look at my poster, which contains a lot more data, and I'm happy to discuss any aspects of my findings and take on board any feedback. Thank you.